Hello everyone. Now we will discuss Python coding for logistic regression, the fourth experiment, logistic regression. Coming to linear and logistic regression, this is the linear regression, this is logistic regression. In the case of linear, we will have infinite possible values, but logistic regression means finite possible values will be present and only continuous data, the data which is the variables which are continuous in nature, we can apply linear regression. But the data which is the variable which are categorical in nature, we can apply logistic regression. And example, we can, for weather prediction, we can apply logistic regression. And now I am going with colab. I am going with colab. And here I will take the diabetes data, and I will apply logistic regression for the diabetes data. And first we have to import the file into colab. So click on this folder option. Once browsing option is given, we can go ahead. Once we get the browsing option, we can upload the diabetes data. So here we are taking this diabetes data into colab. Now I am importing the libraries. NumPy, which is for arrays and matrices, pandas, which is for data structures and operations on numeric data. Then Seaborn and Matplotlib, they are for plotting. These two libraries are for plotting. Now this path, if you right click on the file, left side, you will get the path, you can copy paste. So this path, you can right click on the file, copy path and paste it here. I have already done it. The same path I got when I copied. Now the file is imported into the Python coding. I am going to display first 5 rows in the diabetes dataset. Head means first 5 rows will be displayed. You can see the titles, pregnancy, plasma, pressure, skin, insulin level, PD, age, class, whether diabetes is present or not. These are the 9 headings we have inside the file. 9 headings we have. The last heading is the output. And here we are taking df data frame and assigning the file whichever we have read the diabetes data entirely into df variable. And here is null, anything null is there, we are trying to plot the heat map, the matrix method, and we don't have any null variable, so again empty heat map is present. Now we will calculate the correlation for the df data frame, then we will plot the correlation matrix. You can see the coding here. This is calculating correlation. This is available in the pandas library, CORR function, calculating correlation matrix. It is available in pandas library. We are assigning the values of correlation into correlation underscore matrix. Then we are applying heat map to display the correlation matrix. This gives the linear relationship between the variables. Nine columns are present. You can see diagonally pregnancy and pregnancy, it will become 1. Plasma and plasma, it is 1. Pressure and pressure, it is 1. Correlation. Other correlations we have seen. If it is -1, negatively correlated, +1 means positively correlated. And the percentage values are how much the variables are correlated between them is shown in the matrix. Now I am going with making a count plot for the class variable. Class is the last column. You can see class is the last column. How many test positive, test negative is there, that count I am going to make a plot. You can see here we are having this many number of positive and this many number of negative people who are tested with diabetes positive, diabetes negative. Count plot using SNS library only. We are Seaborn library. SNS is the variable we created. We are plotting now the distribution plot for the age column, and now the plot is available distribution plot. Next I am going with sklearn library, and we are separating the X array and Y array from the data frame DF, okay. We are separating X train, Y train, X test, Y test arrays. Next we are going with modeling the logistic regression. sklearn library has the train test split. We are splitting the data into training data and testing data. We are giving 0.3 means 30% for testing, 70% for training. We have splitted the entire value from the data set. Entire data are divided into 70%, 30% for training and testing. And this function train underscore test underscore split is available in sklearn library. Now from sklearn library we are importing the logistic regression function, also classification method. Now we are framing the model, logistic regression model we are framing by applying the X train and Y train. Next we are doing prediction. After getting reference values, we are applying for prediction. Now Y predict will have the output. After prediction, Y predict will have the output. Now from the sklearn library, we are importing confusion matrix. sklearn library, we are importing confusion matrix. And then we are also importing the variables, accuracy score, precision score, recall score, F1 score. These are metrics in the confusion matrix calculation. We are applying Y test to Y predict, and we are storing the matrix in CM. We will plot and see the confusion matrix also. Now CM will have the confusion matrix classification for the diabetes dataset. Now plotting the confusion matrix. And then we will give names also. After plotting, we will give names for the plot. Y label, it should come prediction. X label, it should come actual. And then title, it should come confusion matrix and show the plot. Heat map is the function used. And here you have confusion matrix. It is a 2 by 2 matrix. And here 0 0, first element is true negative, vertical it is false negative, right side it is false positive. Okay, diagonally it is true, negative followed by positive, and negative followed by positive. You can see here this is true negative, true positive. This is false negative, false positive values. And this is CM matrix, CM 0 0, 1 0, 0 1, 1 1. This is true negative, true positive, false negative, false positive. Now we are applying the formulas, and then we will try to print all the 4 values. From the 2 by 2 confusion matrix, we are trying to get the 4 values. True negative, true positive, false negative, false positive values. So you can see here, these are the 4 values obtained. Based on this, we will calculate accuracy, precision, recall, F1 score. These 4 parameters. We have formulas. So we are applying those formulas. You can see accuracy is Y test, Y predict. Precision is true positive divided by true positive plus false positive. Recall formula is this, and F1 score formula is this. We are printing the values. After calculation, we are printing the values. You can see here all the 4 values of logistic regression, they are printed. Next, still we have true positive rate, true negative rate, false positive rate, false negative rate, sensitivity, specificity. All those we have formulas using the 4 values: true positive, true negative, false positive, false negative. We are applying the formulas and displaying the values: true positive rate, true negative rate, false positive rate, false negative rate, sensitivity, specificity. These are the metrics we obtained for the diabetes dataset after applying logistic regression method. In colab we have implemented. Thank you.